in the world of blockchains and Ethereum Classic. We have several development groups now working, as you know, simultaneously, or you should know, on Ethereum Classic development. And regarding proposals for new innovations, I have a very special guest with me today. I have Luke Wagner of Mozilla. He is a longtime researcher, engineer. He's been there, I believe, for 7 years. He's done research. He's been on the engineering team. So welcome, Luke.
Thank you. Thank you for having me.
Yeah. So why don't we start by you telling me a little about yourself? Like, first of all, how in the world do you have to be like, just this unbelievable stellar programmer to get hired at Mozilla to be working on something that's going to affect, hundreds of millions of people? Or how did you get involved with their?
Oh yeah, well I guess I feel like I just kind of got lucky. I did my master's research in like compilers and VMs and C++ type of things at A&M with Dr. Strautstrup. And so after it was my first job after college was just I applied to Mozilla because I use Firefox and wanted to work on something that I used myself, and I really liked that it was open source. And that's about all I knew about the web. Yeah, it was just a good luck, I suppose.
So wait, did you mean Texas A&M?
Oh, that's right. Yes.
So you went to school there, and was that the C++ founder?
Right. Yeah.
Okay.
Dr. Bjarne Strahlstrup.
Okay. Wow. Okay. So then immediately after you graduated, you got hired by Mozilla.
That's right. Hmm.
Okay. And tell me, tell me some of the initiatives. I don't know how much you could say or not say, but what's some of the cool stuff that you've worked on there in your career so far?
Oh, when I joined, we were just I guess the team already had been deploying our first JIT in Firefox after several attempts before. This one actually shipped called Trace Monkey. It was a tracing JIT. And ultimately, it wasn't the best approach, and we went on. Then I got to start on our next approach, which was called Jaeger Monkey, a very different style JIT. And then after that, another JIT called Iron Monkey, which is still in Firefox today and is really fast. And I got to be part of what was called the Games program, which is a program to see can we make games run fast on the web so that people don't have to use plugins? And if we make the web fast enough for games, we'll allow a whole bunch of other kind of practical things that have had the way paved for them. And then that consumed a lot of my time. And the games program then led to WASM.js, which was this subset of JavaScript where we asked the kind of research question of what's the theoretical limit of how fast can we make this compiled JavaScript code that gets generated by some compiler. How fast can we make it run, and how fast can we make it load? And then the WASM.js success led to everyone being excited about doing something even better, which is WebAssembly, which is where I am today.
Okay. Now, in my mind, when I think of Mozilla, so first of all, it's a cool company because they work on a lot of free software or open source software, and a lot of open source initiatives are not very well funded. There's a few, right? Red Hat, the enterprise district corporation, whatever they do. Well, we know what they do. They make a distribution and help companies. But then Mozilla is like, for all they might be the second biggest open source contributor. Well, there's Google, of course, but I really think of Mozilla as one of the top open source free software contributors. Right, well funded. They're to do all kinds of cool stuff. And so they're gonna continue humming, going to continue doing more cool stuff, continue doing research and releasing it as open.
Oh yeah, we have great plans. It's all about the web, and our mission is to make sure the internet stays as an open global public resource accessible to everyone. So still plenty of work left to do along that mission.
Okay, and then my understanding is Google pays a large sum of money to be the default search engine in the Firefox box. Is that where the majority of the funding comes from?
It's not really my area of expertise what precisely what money comes from where, but I think it's no longer the case that Google's the default search provider. That's Yahoo now.
Okay, okay. But the point is that was so compelling that that made you guys able to get funding to do all this cool open source stuff, and they were okay to pay for that.
Yeah, basically.
So I'm glad Mozilla is around, just like Red Hat, doing a lot of
Oh yeah, me too.
open source stuff. So, all right. So the topic I wanted to invite you on the show to talk about, especially, was WebAssembly. So you've said you've worked on that. So why don't you introduce us and the audience to WebAssembly and why people should be interested in it?
Oh, sure. Yeah. Well, basically what WebAssembly is, it's a standard that defines a format for binary code. So this is the format that goes over the wire and is consumed by a WebAssembly engine, including the one that runs in a browser. And the standard says, exactly how you encode a program in a binary format, and then exactly what it means to run that program. And the design of WebAssembly is such that it's a really low-level instruction set that's meant to be compiled from some high-level language that you would write. Especially, right now we're focusing on C++, but lots of other languages to follow in the future.
Mm-hmm.
And it's a compact format so you don't spend a lot of time downloading it, even when it's not compressed, but even smaller when it is compressed. And it's designed to run efficiently, or at least not require a bunch of backflips to be able to get it to run fast in an engine. And lastly, I guess the last high-level point I would say that's probably relevant here to the listener is it's defined to be independent of both the web and JavaScript. So although that was our primary use case and our leading use case, the core spec abstracts over the host of who's running it. And so you can run it in lots of different contexts.
So, okay, so that last point is especially interesting. So it's not tied to the web, even though it's started for
Has
the
web in its name.
yeah. I
Yeah, a
mean,
bit of a misnomer there.
okay, so but in principle, people, just all the places that people use, like the Java virtual machine, they could in principle use WebAssembly.
Right, yeah, it could be embedded. The virtual machine could be, or a WebAssembly virtual machine could run in lots of places. We're starting to see that now as people are finding new places where WebAssembly, its properties make sense.
Okay. Okay. Now, the reason, just to explain to our listeners, so the Ethereum Classic virtual machine and the Ethereum virtual machine, there's discussions about replacing the existing virtual machine with um, alternatives that can arguably be better for smart contracts. Some ideas that are being banded around are LLVM and then WebAssembly, and that's the reason why you might want to be interested or look into WebAssembly if you're interested in blockchains and Ethereum Classic. Now, what is the status of WebAssembly currently?
So the current status is that we have informally a draft spec that has been kind of given the thumbs up by a lot of people involving the four main browsers, and it's starting to ship currently in release of Firefox and Chrome. It has been since March,
Uh-huh.
and in the pre-release channels of Apple or Safari and Edge. So to be released, on both their desktop and mobile browsers. So it's by the end of the year, more or less, it should be in all the major browsers. So we basically have our kind of initial version nailed down, and we're now working on getting the actual spec, moving that through the W3C process. We just formed a working group, which
Mm-hmm.
is kind of the official group that will kind of make the standard a real standard. And then at the same time, the community group, which is kind of the very open group that's based around GitHub that just anyone can join, is starting to talk about the next waves of features um, that will be implemented next in browsers.
Okay, and how long do you think so it's going to be in browsers before the spec is completed? Is that kind of the standard when these things happen?
Well, yeah, it's interesting. There's this definite synergy between implementing and specifying, where your experience implementing tends to point out things that are impossible or underspecified or counterintuitive in the spec.
Hmm.
And then, of course, the spec, determines what goes into the browser. So we definitely did implementation and specification at the same time. But before anyone shipped anything, we had kind of a quiet period we called the browser preview, where it was disabled by default, but behind a preference that people could start to experiment with. And we used that as a period to let things stabilize and make sure we all agreed. So it is in a pretty stable state, even though the final specification hasn't kind of gone through the full formal process.
Okay. And do you anticipate? I know you guys have a lot of big players, if I'm not mistaken, Microsoft, Apple, Google, Mozilla, of course. Do you anticipate that there, the they there'll be a lot of kind of standstills or nitpicky details to work out? Or
Oh well, fortunately, we that's the that's the hard part we already got through, and
okay,
and I think we avoided a lot of what often you can see in the sort of big dramatic fights in standards. By we had we involved everyone from the very beginning of the design process, so high level constraints that might have caused a standstill were just simply incorporated in the design from the beginning. And basically everyone showed really good faith in the whole process. Everyone's really eager to see the thing finished. Everyone's eager to see it not take a decade. And so we kind of avoided a lot of that sort of stuff. So what we have now is a stable V1 that we all agree on. So we
okay,
yeah.
all right. Now, and but on okay, so it sounds like they're cooperating to move the process forward. But Google had their own initiative, right? The native client,
Mhm.
and so there was competing initiatives, and everybody just decided to bury the hatchet, and they were okay with that, putting together any competing ideas.
Well, interestingly, a lot of native client people contributed a lot of valuable stuff to the WebAssembly effort. So, in some sense, you could think there's some joining of forces here. Although the design of WebAssembly is quite different than the native client in some ways. But if you look recently, there's public blog post from the Google team saying kind of uh, that WebAssembly is the future, and
Uh-huh.
long live WebAssembly and all that. So yeah, so a lot of so I guess we've resolved any of that sort of conflicts in the
Okay.
past.
Okay. And now I have my own reasons why I'm excited and curious about WebAssembly, but I wanted kind of to hear what what makes you passionate, of what gets you up in the morning thinking about WebAssembly. Uh,
Yeah. Well, what excites me, I guess, is just as a general point, making the web platform capable enough that you don't have this decision of, oh, I can go native and be fast, but I'm part of usually a walled garden, or there's I have to install and there's security issues, or on the other hand, there's the web, but it's slow, it's safe, and it has all this great user experience, but it's slow. I want to avoid that slowness downside, so that way there can be no reason not to use the web. So more stuff can move on to the web, and the web can just be this one uniting platform. So a key part of that, there's lots of pieces of that puzzle. A lot of it's about the APIs and IO and how you reach out and touch stuff, but a core part of it was, how do I run code on the CPU? And for 20 years that was JavaScript, and it could go really fast and it could go really slow, and it was hard to predict, even if you really knew performance, even if you're a JavaScript engine author. So what WebAssembly tries to do is just add predictable good performance as a feature that you can use if you need it.
Okay, okay, so you're interested in making the web faster, and why, for the audience, can you explain why the current situation with the JavaScript engine, why couldn't that be faster or fast enough? Can you kind of elaborate on that?
Well, yeah, for plenty of uses, it actually is fast enough. So, and that's why for so long there was only JavaScript, despite 20 years of people proposing alternatives. Is JavaScript is decently fast, and a lot of times the bottleneck's just not in your code; it's in layouts, or it's in the network, or something else. But there is this set of use cases where, if you want to make, an online CAD editor, if you want to do Photoshop on the web, if you want to do a video game, if you want to do video decoding, or if you want to do some sort of custom encryption thing, or just all sorts of cases where you do spend a lot of time just churning through code. And for that one, the central hardness is that it's just hard to predictably get good performance out of JavaScript, because to get good performance, you need the engine to jump over a whole bunch of hurdles. It needs to see a lot of things, and those things are based on heuristics, and heuristics are designed to do well a lot of the time, but it's hard to get them right on all the cases, or even know what the engine's looking for. And so you have a lot of high-level advice out there, like, try to have your code be monomorphic, try not to do this, try not to do that, but it's just really hard without a lot of clear feedback to know when you're hitting that sweet spot. And then lastly, if you have just a ton of code, if you have megabytes and megabytes of JavaScript, just the time to parse all that JavaScript and then warm it up through the interpreter and then through the baseline compiler and then the optimizing compiler and then maintain all the metadata needed to know to optimize. Just all of that can add up to a lot of time, so it can take a while to warm up large amounts of code.
So I'm not a compiler expert like you, but if I was trying to simplify, because I'm a teacher, I try to make things simple. So what you're saying is with WebAssembly, you have compiled code, and it's the compiler that gives you these advantages, right? With JavaScript, you're throwing source code at the browser, and it has to do the best it can with source code, whereas you're so much farther ahead when you have compiled code.
Yeah, that's a good way to say it too. We're taking advantage of a big pipeline that happens before the browser even gets the code.
Uh-huh.
And
Now, okay, but
well, there's still a good amount of work that has to happen within the browser, because, for example, it has to do various optimization passes that specialize this target independent code to be target specific. So WebAssembly doesn't know how many registers you have on your machine
mhm.
and other things like that. So there is some decent amount of work that has to happen, but it's just a whole lot less than when you start with a source language.
Okay, and so the same way that compilers get more and more sophisticated for different platforms, presumably in time, right, the WebAssembly compilers would become, phenomenal and really do a lot of incredible optimizations to make code run that much faster.
Yeah, there is a real possibility there, because unlike native code, we can actually recompile, we can do stuff like profiling, see what your code does at runtime. We can say, you have the newest, chip, x86 chip with this feature. We'll use that new feature instead of the feature that's on every chip. So there are some opportunities for us to do really fast things.
Okay, so it's faster than source code, but it sounds like what you're saying is because we don't know the native platform, it's in the middle, right? So it's still not going to be as fast as native code because the WebAssembly doesn't know the native the details of the underlying actual hardware.
Well, there's two dimensions of performance here. One is load time and one is throughput, like once they're all loaded.
Uh-huh.
And on load time, yeah, we have to do more work because we have to compile this binary code that's platform independent into machine code. So there's a load time angle, and that we've actually done a lot of things to make load time get faster. Like we compile while it's downloading, we compile in parallel. We have a first tier compiler. We do a lot of things there. But the other dimension is throughput, which is once it is running, and that one. We are seeing right now, it really depends on the workload, but often will be 20% slower than native, which is pretty good comparing to where we started with JavaScript. And
Uh-huh.
that difference is shrinking over time. And really what holds us back, the only thing that kind of gets in our way, is we at all times have to be safe and portable. And that's there's a lot we can do within those confines, but that will always be this kind of gap that that native code doesn't have to be safe.
Okay, okay, that makes sense. And then another, I'm thinking I watched this video years ago that maybe you're familiar with it. It was about ASM.js, but it kind of
Yeah.
speaks to WebAssembly. The speaker was talking about, think about decades in the future where we're all running, like you said, these huge applications
Oh,
in
I
the
know which talk
browser.
you're talking about now.
Yeah, and I just thought that that was the coolest thing. But what surprised me about that, one of the things that stood out was he said, you know, hypothetically in the future, 30 years down the road, where ASM.js or now I guess WebAssembly takes over the world, that you could run a Linux program from 2017 and it would run faster in ASM.js. Do you remember that part?
Oh, yeah, this the birth and death of JavaScript talk
Yes, yes.
by Gary Bernhardt.
Okay, and so somehow by doing this in the browser and the whole world adopts it and makes these super awesome compilers, that it's not just going to be portable, but it could be even better than what we have now for existing code. Can you kind of say something about that?
Well, it's I get in the few. I'm not sure how we would generally get much faster than native code. I mean, processors will get faster, so I guess a future processor might run the code faster than today's processors.
Uh-huh.
I can see that people could build whole environments that abstract, that are virtual machines for today's like Linux. And you actually see, people have written not very fast, but whole Linux emulators in JavaScript. There's a pretty famous one, and so it does make sense that you'd be able to host like whole hog, full Linux desktops. Now, there is an aspect which is there's a lot of benefits to using the stuff that's built into the browser, like using the built-in text layouts, text rendering, and all what the browser does with HTML and CSS. There's a whole lot of aggregate value there that
Uh-huh.
it would take a lot of code to emulate all that. So that's usually when people ask, like they hear about WebAssembly, they're like, oh good, I'll render my own HTML, I'll just do my own thing. And that's possible, but it's not necessarily a good idea because the DOM brings with it a lot of accessibility, a lot of interoperability, a
Uh-huh.
lot of integration with a lot of tools, and yeah, so people can do that, but I'm not sure if that will become a common thing.
Okay. Okay. In the video, he was talking about like if you were, let's say, on a Mac and you had wanted to run a Linux program, so you could have a downloaded Linux emulator in your
Yeah.
browser, and then a Windows emulator inside the Linux emulator, and he had like all these levels.
Yeah, and you hear about this. You hear about like IBM's OS 390 or 60. It's that was defined 40 years ago, and it's still running today on radically different hardware. So you probably will see emulation stuff like that where you just have old programs that just absolutely have to run, and yeah, you can emulate them in as soon as you have a Turing complete language, you can emulate them. And
Okay.
so we might see that. And if you look at like the internet, archive.org, the what's it called, the internet history, but they have a bunch of console emulators, so you can play a bunch of old video games now for free. Uh,
Okay.
it's pretty fun. And
Uh,
they're using an emulator that was written in C or C++ compiled to ASM.js. So
okay.
it's some parts that's becoming reality and has been for a year or so.
Yeah, yeah. I don't, maybe not everybody knows about this, but yeah, you could take these huge game engines written in C, C++ today, right? And compile them to ASM.js and run these huge
Oh
monster
yeah.
in the browser, right?
Yeah, and there'll be, tens of millions of lines of C++, and instead of having to rewrite into JavaScript, they're able to just basically compile it um, with
Yeah,
MScript.
yes, that was pretty interesting. Um, now, okay, so WebAssembly is a compelling target that's portable, that's going to get faster every year. Now, why do you think that this effort will succeed where other efforts have not taken over the world? Is there something that makes you confident about WebAssembly more so
Well,
than others?
yeah, well, some of it is that, to some degree, we've already crossed an important threshold where it's, once it's shipping in multiple browsers on
Hmm.
the web in release, it's sort of the boulder is rolling. So in some sense, we already can feel pretty good about this. And I think what allowed us to get to that point, because a lot of these things in the past just have not run on more than one or maybe two browsers. And the problem is just getting a lot of different parties with a lot of different goals and opinions on board.
Hmm.
And that's where when we started this thing, we had ASM.js, which ran in all browsers because it's just JavaScript. There was not a question of supporting it, it was just how well did you run it.
Uh-huh.
And so that put everyone into the mindset of we care, we can see the use cases, we can see people shipping this stuff on live sites, and then we can feel like this WASM.js basically works, but we can improve on it in a few obvious ways. We can make it smaller, we can make it binary format, we can fix some of the performance warts. And that put everyone kind of on the same page to start with. And then when everyone was involved from the beginning, such that this wasn't just why wasn't I consulted sort of, there was none of that. That just put lined everyone up to make a standard that actually shipped.
Okay, so what I hear you saying is that a lot of the barriers to technologies are political, and WebAssembly has overcome a lot of those political barriers, which is not a small achievement.
Yeah, and I mean there are also, I can point out, at length some technical limitations of other approaches too that WebAssembly is able to learn from and address. But I mean the political ones are as bigger.
Okay, now here's my experience with virtual machines, and tell me your thoughts or comment on this. So in the 90s, that was when I heard about Java and their virtual machine and the idea of running the same code on different platforms, and that was compelling. And people started even implementing other languages on the Java virtual machine, which was cool. And then I remember going to a Python conference, and there was talk about implementing Python not just in JVM, the Java Virtual Machine, but also then in what was new then, the .NET, the Common Language Runtime. And I remember one guy getting all excited saying, "No, you don't understand. Microsoft has learned from a lot of supposed mistakes in the JVM, and so the
Yeah.
so much it's better. This one's going to take over the world." And then now in the last couple of years, I've heard about. I keep hearing about LLVM pop up on different articles and mentioned here and there, and some people think that's going to take over the world. And then it's even now replacing the GNU compiler in a lot of situations. People say it's better for using that for the C compiler. Their native the compiler that targets works with LLVM. So I mean, from my experience, it seems like every couple years there's a new and improved virtual machine that's going to take over the world. So what would you say to people that think that in 5 years there's going to be some other technology that's going to replace WebAssembly?
Well, no doubt in 5 years there will be something new. Although maybe people's appetite for new virtual machines has been whetted by the extreme success of JVM and .NET in their respective areas. So, but probably there will always be something new. All those previous things though haven't been in web browsers, and I think that's what's responsible for the success of JavaScript, the language.
Mm-hmm.
The fact that it's in all the browsers, and now with the web's not even just in browsers, it's in WebKit views inside of apps. It's in lots of other places, and so the fact that WebAssembly is actually a web standard and in browsers, I think will give it the same sort of advantage that JavaScript had. And so being when .NET had Silverlight, which was a plugin, and the JVM had Java plugin, but now the web's working to turn off plugins altogether, so that kind of hole in the browser to inject kind of a random new virtual machine is kind of being closed up. So
Okay.
at least on the web, I don't think there will be another VM kind of the Java or .NET style that will emerge. And
Okay.
mhm.
Go ahead. No, go ahead. Go
And,
ahead.
and one other kind of important thing is that WebVM is designed very much to be just another language inside of the existing VM of the web browser. So there's this kind of low-level notion of there's only one VM here. There's just two different types of code, and they're sharing a compiler backend, the thing that generates the machine code. They're sharing a garbage collector. They're sharing internationalization. They're sharing all the API surface. So what that means is the amount of duplication from having two things in the browser is pretty minimal. It's really only, there's a separate parser for JavaScript and a decoder for WASM, and there's a few bits of runtime support that are different, but by and large, these are just two different, slightly different paths within the same big virtual machine. So it's different in respect than if we just plugged in the .NET. In that case, there would be two different whole virtual machines: the JavaScript one and a very separate .NET one. And what this allow WebAssembly to do, for example, is point to JavaScript objects and have JavaScript point to WebAssembly objects in the future when WebAssembly has GC integration.
Okay. So yeah, so from a practical standpoint, you're saying that WebAssembly, their virtual machine it has reasons to argue for its choice for the browser, that because one big one being that it works with JavaScript,
Hmm.
right? Now, but just to be fair, just out of curiosity, well, not fair, maybe that's not the right word, but if that wasn't a concern, if you were just if you just decided today, you know what, I'm going to decide which virtual machine should take over the world, and you are comparing all the ones I mentioned just on their intrinsic technological merits. Can you say something? Because I'm sure there's people out there that they have an emotional connection to those, the JVM, the
Hmm.
.NET. So can you just say something about why it's better? Not just because it talks with JavaScript so well, but why this technology itself is better than this.
Well, yeah, I guess some of it could owe to the fact that, the goal of Java and .NET is kind of different. It's inherently, I think these were designed more for both server side and installed client applications.
Mm-hmm.
And so, and that's kind of a different environment than WebAssembly, which is this very, first of all, it's very networked. So you're sending over the wire the program frequently, and it's part of this very important cold startup time. So the binary size matters a huge deal, and the startup speed matters a huge deal. And I think it's not that this, Java and .NET are really have terrible things for startup speed, but I think WebAssembly being completely designed around startup gives it some advantages in terms of how the format was designed. I mean, at the same time, .NET is a hugely capable VM. I've just been learning recently because the .NET folks came to a WebAssembly community group meeting and they're talking about, publicly and otherwise, how they can generate WebAssembly as a backend for .NET code, and
Okay.
just learning about all the capabilities they have. And they just have a bunch of things for interoperating with native unsafe C++ code that just simply can never be part of WebAssembly because we can't allow unsafety and kind of raw native code on the web in the same way. So in many ways, there's different goals and use cases being served by these different VMs.
Okay, okay. Now I mean I'll be honest, I'm lazy. I don't want to learn lots of different VMs. So I'm kind of hoping you'll make the case why WebAssembly will take over the world and replace a lot of other.
Well, maybe it doesn't. The VM technology, you could think of it as a processor architecture. It's a thing you compile from a source language. So maybe what you're hoping is your preferred language will become ubiquitous, such that you can use it for the server side and for your client side and all the bits in between. Like I hear great things about C Sharp, and if the .NET folks, are able to carry forward, then maybe one day you'll be able to write C Sharp for all the things if that's what you're interested in. And similarly,
Mhm.
on the other direction, the TypeScript is becoming immensely popular and pushing its way into the server. So, and we've talked to them about, with some tweaks to TypeScript, how TypeScript could generate, in some cases, WebAssembly, and then you could use TypeScript everywhere if that's what you're into. So, um, it makes total sense to not, to say I'd like to program in one language with one set of libraries,
Mhm.
and I think that is a realistic future.
Okay. Now, is it a moot point, or is it unnecessary for me to be wanting one VM to take over the world, because you could take the bytecode from all these different virtual machines and uh, the compile or convert one to the other?
Yeah, basically, I would say maybe from the source language. Sometimes the bytecodes they've already lost some amount of information about the source language sometimes. But if you're talking about source languages, that could, it does make sense that they might, yeah, target all the different, both .NET VM and the WebAssembly.
Okay. And also, I was reading something about source maps. So a lot of people, when they think of bytecode, they think of decompiling it to see the corresponding source code. But
Hmm.
apparently, there was some documentation that was saying, no, 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 it's not that bad. It's better than that. And they were, can you kind of elaborate
Oh,
on
sure, yeah. There's this feature that's already, people have been compiling JavaScript from other languages for, a decade now. And of course, you want to open it up and debug it, and you don't want to see this scrambled, minified JavaScript. You want to see your source code.
that? Hmm.
So they invented this debugging format called source maps, which just says how the JavaScript code you generated maps back to the source files. And so what we did is we kind of made the minimal tweaks to that so it applies just as well to WebAssembly. We said those numbers, instead of being line numbers of JavaScript, those are bytecode offsets in a WASM bytecode file.
Mhm.
So today, actually, in Firefox Nightly, you can compile from Emscripten from C++ to WASM and set a flag saying I want source maps, and then you can debug your C++ in the browser.
Whoa. Okay. So, well, I was assuming the source map would be this, like basically like an abstract syntax tree, but you're saying you could make different language, the source for different languages?
Yeah, it's sort of a map. It kind of doesn't care what your source language was. It's really just establishing a mapping from your bytecode offsets or your JavaScript offsets that is in what you generated back to your
Okay.
source language. And then when the debugger wants to show the source, it says, okay, what source file contains this generated function I'm in? And then what line number in that source file should I go to, given
Mhm.
that I'm here in the generated code?
Okay. Now, it sounds like you're saying that you can get a much cleaner, nicer source code uh, representation that corresponds to a binary than you can with other virtual machines. Is that correct?
Well, I don't know if similar source map type things apply to the other virtual machines. I'm not an expert in them. In theory, they could do the same thing, um, but yeah, it is, you can see your identical source files with WASM now.
But I mean, like if you took an arbitrary Java binary
Mhm.
and if you decompiled that, would you get the same kind of?
Well, yeah, you that the JavaScript it decompiles to probably would look not like the same thing you wrote it. I assume variable names would have been stripped, at least
Sure.
if you shrunk that class file. So of course you'll have synthesized variable names and things like that. Now with WASM, of course, there's nothing forcing you to ship the source map, and it's actually a large file. So if a developer doesn't generate source maps, and fortunately they're separable, so you can send down just the .wasm that doesn't have any source maps, and then only load the source map on demand if the user actually opens the debugger. Um, but if there no source map is provided, then what we generate it'll look kind of like assembly. It'll be kind of raw. Um,
Oh, okay. Now I'm understanding. So the reason you could do this awesome source code is because you have this additional
mhm,
data structure called a source map.
mhm.
Okay, I was wondering how they were doing the magic of that. Okay,
Yeah.
that makes sense. And then if somebody wanted to first wanted to obfuscate their code, then they would not ship the source map. If they didn't,
Exactly.
okay, that makes sense. That makes sense. Now, when I was researching WebAssembly for this interview, one thing what struck me was I read somewhere that it's the bytecode is basically a standard abstract syntax tree. It's not really a register based machine code. Can you comment on that?
Yeah, you bet. So there's a sense in which that's still true, and there's a sense in which it changed in one of the last iterations of the spec that we went through. So uh, if you say, what does it mean to run a WebAssembly program today? It is actually a stack-based machine. You start with, when you call a function, it starts with an empty stack, and then as things evaluate, they push and pop from the stack, and it's a typed stack. So and a very, very restricted stack. So you always know kind of statically what's on the stack, no matter how you got there.
Uh-huh.
So in some sense, it is a stack machine, but in another sense, the way we define, if you look at the spec, the way it's described, what we say is there a module, the code that you send over the wire, it's an abstract syntax tree that's encoded in binary. And when you're executing the stack machine, that's those opcodes are part of an abstract syntax tree. So in some sense, it depends precisely what you mean by abstract syntax tree. Um, it's you can kind of describe anything with an abstract syntax tree. It's even if it happens to be bytecode, you can say, well, a module is composed of a list of sections, and then one section is the code section, and it contains a list of functions, and a function contains a list of opcodes. And
Uh-huh.
that's a very simple abstract syntax tree, which still contains a stack machine in it. So it's sort of a choice of definitions, I
Okay,
guess.
okay. Let me try it. Let me try it this way. Would you say that the representation of WebAssembly is a higher level than the the JVM representation in these other virtual machines?
Uh, Actually, I wouldn't say that. It's probably about similar. Um, uh, y- yeah, I get. In some sense, it's lower level. In JVM and .NET, you have these built-in notions of classes. So part of the source language um, type system is built into what you send over the wire. In WASM, our goal is to try to not care about what your source language is and just give you the lowest level building blocks that you generate into.
Okay,
So in some sense, it's lower level. Um,
I see. Okay, okay, because it's not tied to that high level language
yeah, that's
necessarily.
right.
Okay, that makes sense. Um, and and so as you know, Ethereum, as I said, Ethereum and Ethereum Classic, there's discussion about using WebAssembly. Now, and then people have also, some people like the LLVM. What are your comments on WebAssembly versus LLVM?
Well, yeah, this was definitely a question we encountered early on because it was also a question when comparing the WebAssembly approach to the portable native client approach, which used LVM IR's bitcode as their with some encoding, but as their distributable format.
Uh-huh.
And at a high level, I think the biggest difference is that LVM's IR and bitcode are inherently a compiler IR. It's meant to be an intermediate format on your way compiling from the source language all the way down to machine code, and as such, it's entirely specialized to what LVM needs it for, which is not to be a portable standard that has completely well specified semantics that is going to do the same thing everywhere. So if you look at LVM IR, it has a lot of undefined behavior that's inherently built in where you say, if you do this, you shouldn't, but if you do, all bets are off. Like, the missiles could fire, people always joke about what undefined behavior could mean.
Uh-huh.
So there's undefined behavior, and some of the behavior is sort of not completely rigorously specified.
Hmm.
And if you compare that to WebAssembly, we tried to maximize definedness as far as we possibly could. And if you look, we have a list of, first of all, we have no undefined behavior. Things always have a list of specific things that can happen. Never anything, just, well, one of a set of things. And the only cases where we have that are running out of resources because you overflow the stack or
Hmm.
allocate too much memory, which is inherently platform dependent. And the other one is the bitwise encoding of not a number. The floating point value, not a number, can
Uh-huh.
vary slightly simply because different chips do different things, and it would be way slower if we tried to normalize.
Okay.
And so that's, other than those two tiny things, it's completely specified
Uh-huh.
and completely deterministic, which is really important because when you change, just like when you move your x86 binary between different computers, different processors between Intel and AMD, you don't expect it to behave differently
Hmm.
other than maybe running faster or slower. Similarly, you shouldn't expect your WASM to break on one. And so that's, was a very strong reason why we tried to squash out all sources of non-determinism.
I see. Now, if in fairness to LLVM, I believe the way that native client, the way Google tried to solve this problem was you only used a subset of LLVM, and right, and they made basically like a special. They worked off of LLVM and made something that met their needs. Um,
Yeah, you can subset it. I think certain amounts of undefined behavior still remain.
uh-huh.
And and another thing I didn't mention was there's when you have a spec, and we've had this problem before in web standards, you don't want there to be a single implementation that kind of defines the spec, where
Okay.
it's do what LVM does.
Okay.
You want there to be multiple independent implementations,
Yes.
and and that was a problem, if I recall, for web SQL or whatever it was called, that was basically do what SQLite does.
Hmm.
Was, well, there's only one implementation, it's SQLite, and so that would be a problem, is how it's defined. And
Okay.
yeah, a few other things are like that are kind of really technical, is how the stack is treated in WebAssembly. You can't, the only pointers you can have are into this big contiguous array of bytes that are completely well defined. This is memory you allocate, nothing else goes into it. Whatever bytes are there are exactly the bytes you put there. Um, and the stack memory is off limits. The compiler can generate code that loads and stores from the stack, and this is what it does to push, like when you do a call and it pushes the return address,
Uh-huh.
or when you do register allocation and you need to spill stuff to the stack, it goes on the stack. And because that is kept away from the WebAssembly code peeking at it, that cuts off a major important source of undefined behavior, where you could say, well, what happens if I store and I clobber stuff on the stack? What happens if I replace the return address with some random number like that jumps into like my own code,
Uh-huh.
and all sorts of stuff like that? So that's kind of very, I think, baked into the model of LLVM,
Mhm.
and it's very baked out of the model of WebAssembly. So there's, I think, subtle technical things like that that are differences that
Okay,
involve portability.
I see. Okay. Um, now, one argument that the to support what you're doing and to support people in blockchain space using uh, the WebAssembly virtual machine was that you could leverage so much momentum, right? Anything on the web, of course, is used by hundreds of millions of people, and so the attention and care being put to the tools to support it is going to be so much better than anything else. And so it's almost like you you know, why fight that momentum?
Yeah.
Um,
Yeah, I think that's a really good argument to use web technologies to capture momentum.
so like if I was to make my own little virtual machine and had a small community and I was trying to make developer tools, IDE IDEs, right, for my little VM, I would run into issues. Whereas, right, there's going to be so much awesome stuff that Google, Microsoft, Apple, and Mozilla are going to create for WebAssembly. Why would you want to, you know, reinvent the wheel? So,
Right. Yeah, that makes
okay.
sense.
Okay. Now, the as we wind down, the last big topic that a lot that's on a lot of people's minds. So I don't know. I know you've spoken to some people in the Ethereum community, and you know a little bit about blockchains. But one concern with software in this space is because we're dealing with large quantities of money, is the having the software have uh, you know, basically doing what you think it's going to do, what you expect it to do. And you've already spoken to that by saying that you try to eliminate undefined behavior. Um, Now, people even talk about going so far as to mathematically, you know, verify. They want things to be provably secure, mathematically secure. And this is actually not a new idea, right? People have been developing software for think about like air traffic controllers, robotic surgeons, space travel. So can you speak to that need, that desire to have, you know,
Yeah, that
critical code?
well, that makes total sense that people would want that because, yeah, from just as just an observer, I can see the importance when you have these hacks that go on just because there's a bug in the code. And given that I assume these contracts are a little smaller than, like, 10 million lines,
Yeah.
codes, it's going to be a lot more amenable to mechanically verified proof than otherwise. So that makes total sense. And I think this is an area where WebAssembly has a lot to offer because one key thing is the spec is written in already in a mathematical formalism that is very directly, you can mechanize this, and some groups have already. So there's proofs that have been, I think, mechanically verified of the soundness of WebAssembly's type system, and
Mhm.
this just shows that you can turn WebAssembly into something that mathematically verifiable. So if you now have a source language that compiles to WebAssembly, you could prove that the source language to WebAssembly transformation maintains the meaning of the source program. And then on top of that, you could prove that in terms of the source language that it does what it says it's going to do, whatever you want that contract to do. So I think for such a system, you really want your bedrock, the instruction set, which is WebAssembly, to have a completely formal description. And that's what WebAssembly has. And if you go back to your last question about compared to LVM, I think it would be a big novel work to create such a thing for LVM.
Mhm.
Um, and whereas LVM, I mean, WebAssembly has that today, and it's pretty simple as far as formalisms go.
Okay. Now, just to play devil's advocate, what about if somebody says, well, the Java virtual machine or .NET, I don't know if they've formally specified to the level that people want, but
Yeah, so we have a PLDI paper out this just this year about WebAssembly, and it makes the point that the WebAssembly formal semantics you can fit in one page, and with Java and .NET, I think there've only been approximations of the full semantics, just because these VMs do so much,
uh-huh.
and these approximations are hundreds of pages, and still not capturing the fullness of it. So it's really a different order of magnitude of mathematical complexity here if you want to capture the entire platform. Now, if you subset it, maybe you could pare it down, but WebAssembly is really simple by design in this case. And in the paper, it was claimed like it was because we, designed this system with uh, the formal rules in mind the whole time.
Oh, I think that what you just said is going to be music to a lot of people's ears. If you, yeah, small spec, formally defined. I think a lot of people are really going to, that's going to resonate with a lot of people.
Yeah, anyone should head over to webassembly.org and then click spec. It might just be /spec, I forget. But webassembly.org and then look at spec. It's you can see the live draft, and it's all hyperlinked, and it should look like if used to any sort of formal specs in the kind of formal languages community, it should look very familiar.
Okay, great. So you've made a compelling case. You've introduced people to WebAssembly, and you've shown why it has good potential for the future and for more market adoption. Is there like, do you have any thoughts on the next couple years? What should people expect to see on the roadmap for WebAssembly?
So the big thing, which we've kind of more officially kicked off just in our last in-person community group meeting, was the GC integration feature, which is right now WebAssembly has access to this big array of bytes that it can load and store from,
Mhm.
but that excludes a whole lot of what you want to talk to or point at in a web browser, which is all the DOM objects, all of the API objects like file objects and blobs and
Mhm.
sockets and other things. So what this proposal would be is to give WebAssembly first-class references to all these things,
Mhm.
and that means integrate with the garbage collector that's already built into the browser. And what this would mean is WebAssembly could point to DOM things, they could point back to WebAssembly things, and the garbage collector could clean up these cycles. And that's something that's just not possible today. With
Mhm.
WebAssembly, you end up having to stick things into arrays that keeps them alive until you explicitly remove them, which means the garbage collector can't remove cycles. So this is like a huge feature, and it'll take a lot of work, but that's the big exciting thing. And it'll mean that to generate WebAssembly, you don't have to use a low-level language like C++. You could use like C# and
Okay.
other languages.
Okay, great. Now, and then just to repeat something you said at the beginning of our talk, correct me if I'm wrong, but so you said by the end of the year, the all the major browsers are going to support WebAssembly. So this is not vaporware or something that's just being talked about that we have to wait a long time to see in production. But if people could start using this and checking it out right now, or, right?
Yeah,
Pretty soon.
yeah, I totally encourage them to. They can try it out, and yeah, things will run in Firefox and Chrome today, and Safari and Edge pretty soon.
Okay. Well, so it sounds pretty impressive for a virtual machine, for a standard that takes over the world. In all fairness, maybe I should ask you, what would not be something that you would want that you would not want to use the WebAssembly standard platform for?
Well, I guess one answer is trying to compile JavaScript to WebAssembly. It's a thing people keep asking about. It's like,
Okay.
well, and it's inherently you have a JavaScript engine already in the browser, so that's going to run your JavaScript the best.
Okay.
Um, so that, I guess, that would be one. And similarly, if I think JavaScript's a pretty good dynamic scripting language. So if what you want is a dynamic scripting language, I would think uh, using JavaScript would be a good idea,
Uh-huh.
and WebAssembly would be what you kind of reserve for your low-level languages like C++, or in the future your typed high-level languages like C#.
Okay.
Uh,
Okay.
so that would be one example.
All right. So for JavaScript, you wouldn't necessarily want to be obsessing about WebAssembly because you already have great tools in the browser.
Right.
Okay.
And it's it's a good scripting language, and you look at a lot of large applications, they ultimately all of them involve, they tend to grow a scripting language just to script stuff.
Mhm.
And I would hope that people continue to use JavaScript for that, and they are scripting, it could be JavaScript scripting WebAssembly, so you're using both of them for their strengths in a single application. And I think that's what we're going to see more of. So I guess a broader statement of a non-goal would be to kill JavaScript.
Okay, interesting. All right, so great. So I think we've touched on a lot of the bases for people that are not familiar with WebAssembly, and we've talked about how it could be a compelling alternative to the existing Ethereum Classic, Ethereum Virtual Machine, and why it will probably succeed where a lot of other standard efforts have failed. Is there anything else that you want to say before we close?
No, it
We
was a
cover-
great set of questions. Thank you.
Okay, all right. So just want to thank you again, Luke, for talking with me, and I'm sure a lot of people are going to appreciate this interview. And yes, so thank you very
It
much.
was my pleasure. Thanks.
All right. So take care.
You too.
If you are passionate about anything related to Ethereum Classic and you have something